Okay, hello everyone. In this video, we will continue with the states of matter. Okay, now we are all aware of the fact that there are three states of matter, that is solid state, liquid state, and gaseous state. Um, Now here we will be learning more about the physical characteristics of these three states, right? Now the first one is the solid state. Okay, so solid states have um, solids have definite shape, distinct boundaries, and fixed volumes. That means solids will have definite outlines. Okay, and they will always occupy the a fixed amount of space. Then the next one is intermolecular spaces of between the particles are minimum, or in other words, intermolecular forces of attraction are maximum. Now here, if you consider the um, picture here, okay, now we learned that particles of matter have got spaces in between them. Now when it comes to solids, okay, there is very less spaces between them. Okay, now this is attributed to the fact that um, the forces of attraction between these particles, okay, they are very strong, so they are tightly packed. Okay, that is what makes your intermolecular spaces to be minimum. Then the next one is compressibility and rate of diffusion. Now when we talk about compressibility is nothing but the um, ability to shrink its size. Okay, now here, see, if you see, there are no spaces. Okay, practically no spaces in between. So whatever space the particles have is already occupied. Okay, so it cannot be compressed. And the rate of diffusion is nothing but the uh, speed at which particles intermix. Okay, different um, particles of different matters intermix. Okay, so intermixing is nothing but diffusion. Another word for diffusion is intermixing. So here, now, since the intermolecular forces of attraction is very strong here, these particles, they do not break off easily. Okay, they do not separate easily. So they the rate at which diffusion occurs is minimum, very less. Then solids have the tendency to maintain their shape when subjected to outside force. Um, Now, for example, let's say I have a scale. Now, if I apply force on this scale, okay, it bends. Now, when it bends, there is a resistance to, come back to its original form, right? So that is what it means. Okay. Then solids are rigid and they may break under excessive external force. Now, when I'm bending this, that is applying external force, it bends. Now, if I apply more force on it, then at one point there will be, at one point the scale will break. Okay, so that is what it means. Now here, uh, what actually happens here is, if it breaks, okay, that means the external force that is applied is more than the intermolecular forces of attraction. Because see, intermolecular forces of attraction is responsible for keeping the particles together. Now when the external force becomes more than the intermolecular forces, then it breaks. Okay, now there are three things in your textbook that um, is being considered as to whether it is a solid. Now in the first case, it is the rubber band, but again, The rubber band does not change its shape nor its volume when external force is not applied, right? And if excessive force is applied, then it stretches and then it breaks. Okay, so this is a solid. Then the shape of each individual sugar or salt crystals remain fixed, whether we take it in our hand, put it in a plate, or in a jar. Mm, Here, um, see, it takes the shape of the container. Yes, that is true, but it is true only because these particles, the grains of sugar and salt crystals and salt are very small. That when we say a pinch, okay, uh, it contains a large number of solid salt and sugar grains. Okay, it's just that they are solids, but they are extremely small. Okay, so when we put in a container, we're putting in a large number of solid sugar and salt particles, um, crystals. Now, so it is a solid. Okay. Now, a sponge has minute holes in which air is trapped. When we press it, the air is expelled out, and we are able to compress it. Okay. In a sponge, it's just that it has got holes, and then when it is pressed, then the gas is just expelled out. That is why it is, even though it is a solid, okay, it can be compressed. Now coming to liquid state, liquids have no fixed shape but has a definite volume. That means it takes the shape of the containers. For example, this liquid, okay, this liquid is in this beaker, let's say. Now, if I pour this liquid in a container of another shape, then definitely this amount of water will take that um, the shape of that container, right? And then the amount of water will not change. So that is what it means. Now, intermolecular spaces in liquids are intermediate to that of solids and gases. Now, see here, this is what it means. Okay, um, here as compared to the previous picture in the uh, solid state, here the particles have got more spaces, right? Here the particles have got more spaces, and these spaces so this spaces is more than that in solids and then lesser than that in gases. That means the gases will, in gaseous states, the gaps in between the particles will be more, right? So they are fluidic. That means they flow. So they take they take the shape of the container. Now here, see, in solids, it is tightly packed. The particles are tightly packed, and in liquids it is a little bit looser, right? Now uh, that is also attributed to the intermolecular forces of attraction. In solids it is maximum, and then um, the intermolecular forces of attraction is much lesser in that of liquids. Okay, so there are gaps in this. So the intermolecular spaces are attributed to it. Okay, then compressibility again. Now the same principle here. Since there are spaces in between the particles, okay, there is scope for the particles to come closer, right? So it can be compressed, and the rate of diffusion of liquids is more than that of solids. Now this is because since intermolecular forces of attraction are lesser, the particles here, they are more their tendency to break away is more in liquids than solids. That is why the intermixing of these particles with other particles is much faster. Okay, then solids, liquids, and gases can all diffuse into liquids. Now we have done this: solids in activity, sugar dissolving in salt. Then liquids, we did in that experiment, no, the activity where we um, put the potassium permanganate solution in a glass of water, right? Then gases. Now here, see, um, just to give you a little idea, uh, all complex organisms needs oxygen, and these organisms, for example, let's say fish. This is a picture of of this is an underwater snapshot. Okay, so like these are the fishes, these are the seagrass. Now these fishes, they need oxygen, they also need oxygen, but uh, they cannot get it from air, right? Because they don't have lungs, instead they have gills, so they get the oxygen from um, the water. Okay, oxygen that is dissolved in water. Now here again you have the green plants. So if it is green, that means they are photosynthetic, right? So they need oxygen to they need carbon dioxide to photosynthesize. Okay, so from where do they get the carbon dioxide for photosynthesis? They get it from the water. Okay, the carbon dioxide that is dissolved in water is used up by these plants to photosynthesize, right? Now coming to the gaseous state. Okay, now, gases have no definite shape or volume. Okay, um, they occupy the whole space in the container and exert pressure on the surface of the container. Now, see, gases have no definite shape or volume. This is because the particles, okay, the particles, they are randomly moving, right? Um, at high speeds in all directions. All right. Um, that is the reason why they have no definite shape or volume. Then they occupy the whole space in the container. Okay, if it is enclosed, and exert pressure on the surface of the container. Now, just take the case of the balloon. Now, if you press it, okay, there is a force pushing it back outwards, right? So that is the pressure exerted on the surface of the container from the inside, right? Okay. Now, this is because since the particles are randomly moving around at high speeds, okay, the collision of the particles on the surface from the inside exerts pressure, okay, on the surface. Now, intermolecular forces of attraction are minimum, okay. There is a very negligible amount of um, intermolecular forces of attraction. So that is the reason why they have large gaps in between them. That is intermolecular spaces. Okay, they are highly compressible. Now, since in gases there is a large space between them, okay, that means there is a huge scope that these particles can be brought closer to each other, right? So they become highly compressible. Rate of diffusion is more than that of solids and liquids. Now, since in solids, no, sorry, in gases, since the particles are moving at much greater speeds, okay, they are much more faster uh, in diffusion. Okay,